Okay, Lamai. Earlier we discussed about reactivity of metals in the last video. So, under reactivity of metals, we have to discuss about reactivity of metals with air, uh, with water, and with dilute acids. So, in last video we discussed about the reactions of metals with air. This air part we done and we've done, and now we have to discuss about reactions of metals with water. Okay, so some metals react with cold water. I'm going to highlight this part with water. So here we are going to discuss about reactions of metals with water, the second part. Some metals react with cold water, hot water, and water vapor at different speeds. So you should understand these three things are different. It's cold, one is cold water, the second one is hot water, and the water vapor. So from cold water and hot water, what thing which you uh, think that is react with very fast? Is it cold or hot? You should understand it's hot water. So some metals react with cold, hot water and water vapor at different speeds. Hence, it is clear that reactivity of metals towards water differ from one another. To confirm this, let us do activities, the below activities. The requirements are trough, water, a piece of sodium metal, red litmus paper. We have sodium metal and water. Okay, so under guidance of teacher, because sodium metal is very reactive, very active metal, so you should have the guidance of a teacher, otherwise there could be explosion or other things. Under the guidance of the teacher, add a small piece of sodium the size of the seed of a green gram to the water in the trough. Record your observation. The piece of sodium darts on the surface of water swiftly with a hissing sound. The piece of sodium, which is small, catches fire if it stays motionless. The red litmus paper in the trough turns blue. Sodium reacts violently with water, liberating hydrogen gas. Turning red litmus blue shows the formation of alkali. Basic solution. What happens here is that sodium reacts with cold water, giving sodium hydroxide. I'll show you the videos later. Before that, I'll show you the videos later. Before that, let's finish this part. What happens here is that sodium reacts with cold water, giving sodium hydroxide, a basic solution, and hydrogen. This is the thing which happen in here. So let's highlight like this. Cold water, sodium with cold water gives what? Sodium hydroxide, and it's a basic solution. This is a basic solution, and also hydrogen is given. Let's see whether it is balanced. 2Na, 2Na, 2 into 2, 4 hydrogen, 2 here, 2 here, 2 oxygen. Okay, correct. So what happens in here? Piece of sodium darts on the surface of water swiftly with a hissing sound. So let's highlight the observations in a different color. Hissing sound. Sodium darts on the surface of water swiftly with a hissing sound. The piece of sodium, which is small, catches fire if it stays motionless. Motionless now, it catches fire. And what happened to the red litmus paper? Turns blue. Turns blue. Litmus paper turns blue. These are the three observations we get here. Sodium reacts violently with water, liberating hydrogen gas. Turning red litmus blue shows the formation of alkaline or basic solution. I think you get this part. Okay, I'm going to show you a video later. Yeah, in the next video I'll show you the video. For this instance, let's go to the next activity. Activity 16.5. Requirement is a beaker, water, clean magnesium ribbon. So you already know about this magnesium thing, clean one. Remember, it's clean magnesium ribbon. And put the clean magnesium ribbon into the beaker of water, record the observation. So what happened here? Heat the beaker of water with the burner, record the observation. So you have to put that clean magnesium ribbon into water and you have to record the observation. It does not give a really fast reaction, speed reaction as it gave for sodium, but when you heat it, it will give a kind of reaction which is very visible. So let's see. Magnesium does not give any observable reaction with cold water. Does not with cold water. But when reacting with hot water, what happened? Liberation of gas bubbles can be seen. Magnesium react with hot water. So in cold water, you do not have any visible, observable reaction. But when it comes to hot water, magnesium reacts with hot water with giving magnesium hydroxide and hydrogen gas. The liberation of gas bubbles means H2 gas. Okay. Then magnesium reacts fast with steam. When it comes to steam, not water, reacts fast. Mg reacts fast with steam. The products of the reaction are magnesium oxide and hydrogen gas, MgO, and also hydrogen gas as previously. But in the previous case with hot water, it gave magnesium hydroxide. But when it comes to steam, it gives magnesium oxide. Okay, instead of magnesium hydroxide, it gives magnesium oxide. Aluminium and zinc do not react with cold water or hot water as same as magnesium. Aluminium and zinc also do not react with cold water or hot water, both. Okay, but on steam, when react with steam, it gives they form the corresponding oxide. Corresponding oxide means for aluminium it's aluminium oxide, for zinc it's zinc oxide. So the corresponding oxide, that means corresponding oxide means because they have mentioned two metals in here, no? So for aluminium it's aluminium oxide, and for zinc it's zinc oxide. So they have given one example equation here, but I am going to give you both when I give you the note. And liberate the hydrogen gas. Iron does not react with cold water. Yeah, when we come to iron, it does not react with cold water or hot water. When heated in steam, it gives a metal oxide and hydrogen gas as same as aluminium and zinc. So think the most reactive one which reacts with cold water is sodium. So that's why sodium lies as a second metal in the activity series. But what about magnesium? It only reacts with it does not show a visible reaction with cold water, but when it comes to hot water and steam, it gave the reaction. So that's why it comes below the sodium. Okay, magnesium comes as the fourth of the activity series. It comes below the sodium. And the last ones which do not react with even cold or hot water but only react with steam, that means they are somewhat strong, like, no? So they comes below, it's aluminium, zinc and iron, they comes below in the activity series. Okay, thank you. I'm going to stop here and thank you. I'll discuss the other part later.